Hi, and thanks for joining me. Another video on icing. Our current discussion is concerning structural icing.
And specifically, we're going to start discussing climatology in this video.
The climatology of icing means the long-term trends of icing. Where do you find icing? What time of year? What locations? And we can break that down into the availability of supercooled liquid water. Where do you find supercooled liquid water? Because that's what causes ice. Also, certain types of clouds tend to have more icing than others. And then also, there are places where you tend to find icing more frequently than other locations. So we'll look at common locations for icing also. First, we'll start out with the availability of supercooled liquid water, and that depends upon the temperature and also the age of the cloud.
First off, we're going to talk about supercooled liquid water, and we already discussed this back when we talked about the requirements for icing. Supercooled liquid water, of course, is liquid water at temperatures colder than 0 degrees Celsius. And the reason you have supercooled liquid water is because ice nuclei really don't start to work. They don't start working until temperatures colder than -20. When they get to -20, they start to kind of scavenge all of the liquid water out from cloud. Remember back in your basic cloud physics and your introductory meteorology class, the different types of precipitation processes. There's the warm cloud and the cold cloud. What we're talking about here is the cold cloud process, where ice crystals tend to grow at the expense of water droplets. In other words, ice crystals will grow and water droplets will actually evaporate, because the saturation vapor pressure over ice is less than the saturation vapor pressure over liquid water droplets. So because of that, you tend to find the most liquid water content, supercooled liquid water content in cloud at temperatures between 0 to -10 degrees Celsius. And then we said that certain ice nuclei start working at about -12 to -15 degrees Celsius. So as a result, somewhere between -10 to -20, you start to see a mix of ice crystals and liquid water droplets in cloud. But generally, at temperatures colder than -20, most of the cloud is mostly made up of ice crystals. Another thing that determines the amount of supercooled liquid water, or the liquid water in cloud for that matter, is the cloud-based temperature. If the cloud-based temperature is warm, then you're going to have higher liquid water contents in cloud. Think of it this way. You know that the cloud base is where you have 100% relative humidity, which means the temperature is equal to the dew point. Remember that the dew point tells you how much water is in the air. So if you have a very high dew point, you're going to have much more liquid water or water vapor in the air that can be turned into liquid water through condensation. So warmer cloud bases generally imply a much juicier, much more succulent, higher liquid water contents in cloud. Whereas if you have very cold cloud bases, we're looking at temperatures of 0, -10 or so. Cold cloud bases means that there's the dew point, temperature and dew point are cold. The dew point being cold means that there's not much water vapor that can be condensed out or converted to liquid water droplets.
Another thing to be mindful of is cloud top temperatures. With cold cloud top temperatures, we're saying a cloud that extends up through -20, maybe even -30, then you are going to have many more active ice nuclei, which are turning supercooled liquid water droplets into ice crystals. As a result, that decreases the liquid water content in cloud, which means that you will have less structural icing when flying through these clouds. However, if the cloud top temperature is warm, we're saying temperatures of maybe -10 or warmer, then there are going to be fewer ice nuclei active, and as a result, you're going to have a lot more supercooled liquid water and a lot more icing in cloud.
So, of course, it goes without saying that very cold clouds like cirrus, cirrostratus, and cirrocumulus don't have any liquid water. They're mostly ice crystals because they have their very cold temperatures. And as a result, those types of clouds don't have any ice. Also, we talked about the age of clouds before. We said that young clouds tend to be juicier, more succulent. And the reason for that is because young clouds have just produced or just generated water droplets, and it takes time for the ice crystal process to form in cloud. So generally speaking, if you're looking at a cloud and it looks like cauliflower clouds usually are a good indication of lots of supercooled liquid water if they have very crisp edges. But if they start to get fuzzy, like this picture shows at the top of clouds, fuzzy clouds usually means that the ice crystal process is started in cloud. And once ice crystals form in cloud, they very quickly propagate throughout the rest of the cloud at temperatures colder than zero, of course. So when you start to see these fudgy edges, that means that there are ice crystals in cloud, and the cloud is being converted to mostly ice.
Next, we'll look at the characteristics of different clouds and the icing that is expected in them. We're going to break down our discussion into either stratus clouds or cumulus clouds. These are the two most common types of clouds. First, stratus clouds. Stratiform clouds, icing can be found typically at low altitudes and mid altitudes. High altitude stratus clouds are usually cirrostratus, and those are made mostly of ice crystals. So I would say anywhere from the surface up to 20,000 feet, but of course that varies with time of year. During the winter time, it's going to be much lower. During the summertime, stratus cloud icing can be a little bit higher, up to 20 or so thousand feet. And then typically icing layers are usually about 3,000 to 4,000 feet thick. At least that's what climatology has shown at research studies. So if you are able to change your altitude by 3,000 to 4,000 feet, more than likely you'll get out of the icing conditions if they are stratiform clouds. Typically, the icing intensities in stratiform clouds is light to trace to light icing. However, that can vary also depending upon the temperature profile of the atmosphere and the source of moisture. But generally, it's trace to light icing with the greatest accumulation of ice at the tops of clouds. We've talked about that in other videos. And usually, the type of ice you expect would be rime or mixed. You can see clear under certain conditions where they're SLDs. Next up is cumulus clouds. Cumulus clouds typically form in the spring, summer, and fall. They also form in the winter, but typically closer to the Gulf Coast of the United States. Of course, cumulus clouds have very strong updrafts, and as a result, they produce very high liquid water contents. Remember that cloud-based temperatures for cumulus clouds are warmer typically than stratus clouds. Usually during the summertime, dew points are a lot higher. There's a lot more moisture in the atmosphere, and as a result, you have warmer cloud-based temperatures. And we discussed cloud-based temperature and how it relates to liquid water content. So, of course, cumulus clouds tend to have much higher liquid water content than stratus clouds. Remember that also cumulus clouds have the collision coalescence process, a warm cloud process occurring within the cloud to produce precipitation. And that's where smaller droplets balance into other droplets and become bigger. Those bigger droplets produce cloud drops that are bigger than 50 microns. And 50 microns is the definition of SLDs, supercooled large drops. So cumulus clouds, you tend to find supercooled large drops. And remember that SLDs, most aircraft are not certified to fly into SLDs. Only newer aircraft certified after 2015, if they so desire to have the SLD certification, will be certified. So it's best to stay out of cumulus clouds and circumnavigate around those.
So with cumulus clouds, of course, you tend to find the worst icing at, of course, warm temperatures, 0 to minus 15. It's possible elsewhere, even at temperatures colder than -20 because of the strong updrafts lofting liquid water to high altitudes. And of course, you can get icing in any season in cumulus clouds, even in the summertime. If you're flying in the summertime, and a lot of people think the summertime there's no icing. Aha! If you get above the freezing level, you're going to get icing, and that does happen.
Of course, cumulus clouds have great vertical extent. You think about during the summertime, the freezing level is typically somewhere around 14 or 16,000 feet. And if you look at the typical range for icing from 0 to -15, if you use the standard lapse rate of 2 degrees Celsius per 1,000 feet, that gives you about 7,500 feet. You add that to your freezing level, and that means that you're going to see icing all the way up to probably the mid-20s, 23, 24, 25,000 feet. So icing can extend to great altitudes during the summertime. And as a result, it's usually best trying not to outclimb the ice, but to navigate laterally around the cumulus clouds. Typically, cumulus clouds are only about maybe 3-4 miles across, and that's not too far to go out of your way to avoid icing. The type of ice that you get in cumulus clouds typically is glaze. At colder temperatures, you'll see typically more of a mixed type of ice. And at very high altitudes, if there is still any liquid water left, you might see more of a rime at much colder temperatures. Remember, with high liquid water contents, you tend to get glaze or mixed or glaze ice to very cold temperatures, actually. Icing intensity depends upon the cumulus cloud, if it's a very large one, a very small one. Typically, small cumulus clouds will have light icing in them, perhaps maybe even moderate. But as you move towards the towering cumulus clouds and the cumulonimbus, even short encounters, we're talking 30 seconds, will coat the aircraft in about an inch or so of ice. So that would be a severe icing episode in towering cumulus and also cumulonimbus. Next in our discussion of icing climatology is the common locations where you find ice. As you know, clouds form as a result of air rising and cooling to reach its dew point. When the dew point is obtained, saturation occurs and water vapor converts to liquid water droplets in our atmosphere. So you're going to find icing where you have clouds, and clouds form as a result of air being lifted through our atmosphere, and also that moisture in the atmosphere being abundant enough to reach saturation.
So the lifting mechanisms, of course, provide the updraft required for the clouds. Can be mountains, can be convergence, jet streams, fronts, things like that. And of course, the closer you are to a source of moisture, like the Gulf Coast or the East Coast or West Coast of the United States, the more abundant moisture there is in the atmosphere. So you can think that places where you have good lift and you're close to a source of moisture, you're probably going to have a lot of ice.
There are a few places where icing tends to be more common than others, and we're going to start out with our first one, discussing mountain regions.
Mountainous areas, once again, have a continuous lifting mechanism, and then also if those mountains are close to a coastal, close to an ocean or bay or lake, then they are near a source of moisture. So the moisture is feeding the updraft and producing clouds. Typically, these clouds tend to be young clouds. They're constantly being lifted and they're constantly producing new clouds. This is prime regions for a high liquid water content and for icing conditions. So where do you find ice? Typically, you find ice where you have the high liquid water content. Where do you have the high liquid water content? You have it in the updraft region of the mountains. So that would be on the windward side of the mountains is where you would expect to find icing. And of course also in the updraft region of altocumulus standing lenticulars. Some of the worst icing I ever experienced was during the spring over mountains. The mountains tend to heat up a little bit more, especially if you have a weather system moving through and the atmosphere is unstable. You start to get towering cumulus. Towering cumulus tend to produce, cumulus clouds tend to produce a lot of big droplets. So you get severe glazed type of icing or clear type of icing. And you're flying at higher altitudes where your aircraft may not necessarily have the greatest performance. And as a result, as you start picking up ice, you start descending into mountains. And that can only lead to bad things. The next place we're going to talk about where you find icing is in the downwind of lakes, what we call lake effect ice. And what happens here is you have a warm body of water that is continuously evaporating into the atmosphere. If cold air moves over this warm body of water, it produces an unstable situation. Warm down low, cold aloft. Warm air right above the lake tends to rise and produce clouds, and these clouds tend to have rather warm cloud-based temperatures. Remember, once again, warm cloud-based temperatures produces high liquid water contents in cloud. One thing to look for when you're considering lake effect icing is the air-lake temperature difference. This is what meteorologists use when they're forecasting icing and forecasting heavy snow events downwind of the lakes like Buffalo, New York, and places like that. That's what we call the fetch. As the air travels over a large body of water, it tends to pick up the moisture. The bigger the air-lake temperature difference, the more unstable the atmosphere is, and as a result, the more clouds you're going to get. So typically, downwind of large bodies of water, we're talking for lake effect, the Great Lakes states of Wisconsin, Minnesota, I guess, can be included in that, but also Indiana, Illinois, Michigan, Ohio, Pennsylvania, and New York tend to see a lot of this lake effect snow. So these clouds typically don't go to high levels unless, of course, you have a major weather system moving through. But you can have cloud bases with lake effects types icing conditions with clouds up to 6,000 or 8,000 feet. You tend to find it when the difference between the air and the temperature is the greatest, or the air temperature, I should say, and the lake is the greatest. In other words, when the lake is warm and the air temperatures are cold, typically that happens when cold air comes moving out of Canada, and that usually happens in the fall and also the early winter. The type of the ice that can occur, the intensities can be moderate to severe depending upon the liquid water content and the drop sizes. And you tend to get all sorts of different types of ice, mixed, rime, and glaze I have seen. And it all is a function of temperature and also liquid water content. That's all we have for climatology for this section. There is another climatology video, so stand by. You might want to click and look for that one. So talk to you later.